Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for exam FM on financial mathematics. Consider a $100 par value 15-year 4% bond with semi-annual coupons. The bond is callable at 109 on any coupon date starting 5 years after issue, at time 5 exactly, for the 5 years that follow, and then at 105 starting 10 years after issue for the 5 years that follow, except for the maturity date when the bond matures at 100. What is the highest price an investor can pay for this bond to be assured of a yield of 3% convertible semi-annually, no matter whether the bond is called or not? And here's the solution. An investor who buys this bond has the following possible alternatives. Receive 109, the first call price, paid at time 5, or at time 5.5 or 6, etc., until time 9.5, plus all the $2 coupons through the date when the bond is called. Or receive 105, the second call price, paid at time 10, 10.5, and so on, until time 14.5, plus the $2 coupons through the date when the bond is called. And the third alternative is receive maturity payment of 100 plus $2 coupons through maturity, $2 per half a year. If the bond is called at time 5 and the rate of return is 3% compounded semi-annually, so really 1.5% per half a year, then the appropriate price at time 0 is $2, paid as an annuity of over 10 years at 1.5% plus 109 discounted also at 1.5%, and that's 112.37. If the bond is called at time 5.5 and the rate is 3% compounded semi-annually, then the price is again $2 coupons plus the present value of that call value. That's 112.68. Note that the second price is higher because the bond is selling at a premium, offering income of 2% per half year, while the market yield is 1.5% per half year. If the bond were amortized, this difference in income would be covered by the amortization process. Higher coupons advantage would be offset by a reduction in bond's premium. But in this case, the call price stays the same until time 9.5, so that the price resulting from a call before time 10 will be more than 112.37 and will go up as you defer the call. So for the call price of 109, the highest price at yield of 1.5% per half year results if the bond is called at the latest possible time with that call price, so at time 9.5. That price is actually 115. It's calculated here. Now if the bond is called at time 10 at 105, the price at time 0 at 3% compounded semi-annually will be 112.30. Between times 5 and 9.5, deferring the payment increases the value at time 0 of cash flows, as income produced is higher than the market yield. But here we also have, initially at least at time 5, a lower value of principal paid when the bond is called, going from 109 to 105, so the price initially is significantly lower. Later calls will only increase value, however, because bond's income is higher than the market yield. So you produce income at a higher rate than you discount, and that's why the amount is higher. And the latest date for a call at the price of 105 is at time 14.5, resulting in the price at time 0 of $2 discounted coupons for 29 periods at 1.5%. Now we're discounting all this at 1.5% because that's the yield we want to get, and we're trying to figure out all the possible outcomes and how much they're worth at 1.5%. And then we will figure out the lowest of all those possible prices, and that means that if we pay that price, we cannot get any less than 1.5% yield because every other outcome will produce a better result. That's roughly the idea of what we are doing. Anyway, so this is $2 coupon over 29 periods at 1.5% plus the present value of that call value at time 14.5. So discounted over 29 half-a-year periods at 1.5%, and that's 114.93. Now, if the bond is not called, it's just redeemed at maturity, then the price today of all the coupons plus redemption value of 100 after 15 years, so after 30 half-a-year periods, is 112.01. So the possible values of the bond at time 0 to yield 1.5 per half year are 112.37, 112.68, and so on, up to 115, then 112.30, and so on until 114.93, and the final one at redemption 112.01. Each value corresponds to a specific outcome, and in that outcome, that is the price at 1.5 per half-year yield. If an investor pays in that specific outcome a price that is higher than the one named, such investor will receive a lower yield. And if the price paid is lower, the yield will be higher. In order to get at least 1.5% per half year in all of those possible outcomes, the investor must pay only up to the lowest of those prices, so 112.01, which is answer A. Please remember, this is copyrighted material. The problem is written by me, and the solution is mine. It was published in 2010 as one of my exercises, posted then in a PDF file. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on the test.